installed on his laptop, could be a different version, and while he's developing, he's using that, and he pushes the code to the production, and the production fails because the mismatch of these libraries and binaries which the developer was using. So there were a lot of issues in terms of from a development perspective, from a packaging perspective, and pushing these code to the production perspective. So there is a kind of things happened in while containers came into picture, everything changed. Most of the things in a virtual machine era, it was all VMs as a unit of scaling as well, right? So in a containers era, it is more of packaging. So how do you package an application with the all the dependencies together and build it as one single um, container, build it as one single package, and then reuse the underlying hardware where there is no issues with respect to building the applications. For example, I can have a container with JDK8, um, OpenJDK8, and I can have a container with OpenJDK 12 on the same VirtualBox and within the container ecosystem, and use both the containers. There is no dependency issues will happen. If it was a VM, then I would have installed only one JDK and I would have used it in a different way, and there would be a different clashes between two different applications which is running, or between the same applications with different code which is there. It's also been very difficult to execute. So there is a reason why containers came into picture, and there is a reason why packaging became a very important factor as well, where you're taking all your applications to the cloud very fast, while your packaging is right. So the developer environment is equal to the production environment, so there is no issue, right? And if both of them are using container strategy, then there is no issue in terms of getting your code directly to the production. So that's the main reason why container came into picture. And from a traditional environment perspective, you can see that how exactly this used to be, right? It's kind of hardware, host, and hypervisors coming into picture. But in an advanced containerized environment, your resource utilization became pretty easier. So if you see this diagram, right, there is a hypervisor, there are containers on virtual boxes, and you can see the resource utilization is more if you're not building it right. But in a containerized environment, you can host all the containers on different on a single box, and still there is no clashes between the binaries which you have installed, or the shared libraries is not an issue. So it's obviously run through an engine which is Docker engine which is there, so it's pretty easy. And also, as I told you, right, it's kind of migrating from one environment to another environment is pretty easier if you have a containerized strategy, right? For example, as I told, right, developer environment is equal to production environment, which can also be that in production there could be two different virtual boxes where you have hosted containers, and something happens to one of the virtual boxes, and you need to move the containers from you need to move the application from one virtual box to another virtual box. It's really difficult if you are not containerized strategy. It's kind of, you have to write scripts, you have to write Ansible scripts, you have to do a lot of things. You have to make sure that environment is same and everything to get into that specific. So this is how you can actually use, by pushing all the things into one environment just by building a container, right? So the benefit of using it, I'm just focusing on these couple of things. One is agility, that is ship fast. We already discussed it, and it is easy to port. We will see why from a demo perspective. And then there is achieve, obviously resource efficiency is achieved when you are building the small packages of your applications, and you can host it in different places. And then obviously scale part of it, which we will see as a simple example with Kubernetes, but that again, that's the later part. So I'll just deep dive into demo because there are a couple of things which I need to show, and we need to do a lot of activity there. So let me go back to uh, my Visual Studio. I hope everybody can see my Visual Studio.
Yes, Vivek.
Okay, perfect. So let me start with this, how exactly this works. I just want to go through the steps, how things work and in the real world, right? You have a piece of code, and what you will do is you take this piece of code and create a Docker file. When I say Docker file, it's kind of a configurations. When I say configurations, it is it is related to that piece of code. How you can run your code. What are the dependencies which are required to run that specific code. You're packaging it together as as a set of commands in a Docker file, and we will see what are those set of commands which are available and how to package it in the demo part. But just remember that the Docker file is nothing but kind of packaging it, right? And you're packaging it, and what you do is once you have created the Docker file, you're given that configurations in the file, and then now you want to just you know create that image. Well, when I say image, it is nothing but you're creating that artifact. You're packaging it and hosting it somewhere or keeping it somewhere, and then what you're doing is you have something called as container registry. So when I talk about container registry, right, it is nothing but a single place where you keep all your artifacts. You keep all your images at one central place where you can reuse these packages. For example, there is a developer 1, 2, 3 who is working on various things, and developer 1 can push build a new Docker file and build a new configuration file through Dockerfile and build an image and push it to the container registry where the centralized location, and developer 2, developer 3 can pull that that image onto his laptops, and then reuse those images for various things. Or even I can pull it in production and reuse that image in the production itself directly, right? So when I talk about container registry, there are three kinds. One is uh, public cloud provided, which is Azure provides a container registry as a service where you can host all your images, or you can also build your own private registry and use it, or you can also use something called as Docker Hub, which is the Docker's own registry available out there. There are a bunch of open source images which are available already, and you can directly download it from there. And I'll show you how a couple of things can be done here. And I mean, this is about how you go about using Docker from a development perspective. You have a code, you have a dependencies for that code, you package it, and you build an image, you push it to the container registry and host that image at some place, and then you developer 1 or 2 3 or production and DevOps engineer pulls that image onto the production and runs that container. So the difference between an image and the container is that images is a build image which is not running, and containers when I'm talking about containers, it's the containers which are running. Okay, it's the code which is running is called containers. Okay, that's the analogy you need to keep in mind. So given that, let me show you what example I have. I have built a simple Java application. You can see Java code, which it is just doing a simple thing. It's basically printing today's time. I mean, time right now, and saying, "Hi developers, this is JDK latest." So we can call this as OpenJDK 8. This is JDK 8, and I'm going to save this code, and I'm going to talk about, this is the code which which I have, and and this is a Docker file to execute that code. But even before I go into this this building of this Docker file, I just want to introduce you to a couple of commands of the Docker, right? This while building Dockerfile, what are the things you need to keep in mind? One is the from, right? And it's a from is one of the command which you need to provide, and you can see in my Dockerfile as well. I have given from OpenJDK latest. That means the latest image available on Docker Hub. Pull that image and host it here. Host it in my Docker environment. Okay, for that specific image which or command or the container which is going to run. So basically it can be of two types, right? And it can be a base image. From that could be a the I mean it could be Ubuntu or other OS images like SUSE Linux or other Linux which we have, or you can start with the OpenJDK or anything where basically you already have a set of images on top of it. So by default, it is always in a Linux image which is there. So you can start with any of these images which is already there. And coming to the environment, env is nothing but you are setting up port and other things. It's an environment variable. So any environment you are setting up, you are either using these port numbers or other things which is required. And working directory, which is it's basically a context. So you are telling get into the Docker space, the engine space, and then go into this working directory. This is where my application is. This is the command you need to run after going into this working directory, and this is what you have to do. So all these things you're setting up the how this code has to be executed. What are the things required for this code to be executed? Entry point is nothing but it's kind of an whenever this Docker is running, this is the executable command which is going to run. And command is either you can either give and give couple of variables to one of the command. You can run and give that variable to entry point, or you can override the command which is there while you are running your Docker command. You can override that as well. And the copy is nothing but you're copying from the location, the source the um, to the working directory, which is this is the working directory, which is to couple of to the location where inside the inside the Docker space. So and then you're adding add dar.zip is nothing but it is just unzipping and other things, and run command is to run a specific command which is there, and you can see that it's a specific command you can run. And expose is expose the port from which you can connect to the this specific container. So as I told you, right, containers are independent and these are packaged independently, and it has its own libraries and binaries in the code. So it is running independently, and if one container has to talk to another container, there has to be a connection between these two, right? So let me go back and show you how to build it. So I'm copying, sorry, I'm starting with from OpenJDK, which is I'm giving it as latest. But what we will do is we will change this to 8, and I'm taking the 8, not the latest one. Remember that I'll show you. I have already built a image with latest as well, and now there is copying from the source to inside this specific path inside the container, and then there is working directory, and you can use this. I'm I'm going to this path. So when I say copy dot, it means from my local laptop into the container. And then there is a run command. I'm running javac, I'm compiling it. And then there is an entry point. That means whenever there is this specific Docker image is running, it runs this command. Okay, so this is I'm almost used up all the required commands which I explained. So let me go back and show you a couple of things in. Okay, so Docker images. Okay, you can see my images. This is Docker images. Okay, cool. So I've already built a couple of images just to make sure that we don't spend a lot of time in downloading a couple of images and running it. And when I say Docker run, this is one of the command to run the Docker. Docker obviously it's a CLI. You can install the Docker CLI, and you can perform a lot of activities there. And Emma, if you need help, you can just type in help and um, you can see all these commands. So if you gain mastery over this, I think you can build almost anything in Docker, right? So this is an amazing set of help is available. So please go through this and learn about this and play around with all of these commands. Let me go back and say Docker images. This is one command to list all the images which you have on your on your laptop. And Docker run 447. What is 447? It's the image ID. Either you can copy the complete or you can give the first three and run it. And this is again the one which is on my local laptop. This one is on the registry, container registry, which I have it on um, on Azure registry, but the image ID is the same if you see. And I've just pushed this code to the container registry. I'll show you that as well, how you can push it, how you can build it and push it. So this is Docker run 447. If I do this, this was built on JDK latest, right? And we did change this to 8. If you see the code change which we build that now. I'll show you how to build it. Path where I have the Docker file, all the code, all the things required, and Docker build my Java app, my Java app 8 version 2, right? Oops, dot. Oh, sorry. Template. Okay, so it is obviously, if you see that it is using OpenJDK 8. If I had set the code to to latest here, it would have used the latest, but I have actually set it to 8. It is downloading the Open JDK 8, and it will take some time. Um, while it is taking time, let me show you what I have done. So what I've done is I had built the code. I have the Docker extension installed on my Visual Studio, and I have Azure Cloud connected to the registry. And you can see here, my registry is available, and there is one specific image available on the registry as well. Um, this is the registry, and by the way, and this is the image which is there in the registry. What I did was I built, the app here, and it's very simple. Just right click on it, and you can actually see either you want to push it, you pull it, or tag it, or what you want to do. So either push it, I pushed it. I push when I click on push, you will, you can see that there is Docker and other things which will show up. Um, so I think it's already there. Let us see what's going on. So um, so this is just you're pushing it the image. If you want to download the image from here, you can obviously download as well. You can just say pull, and you can pull it from the container registry itself. So if you click on pull, you can actually get the code itself. Okay, so let's wait for this to happen. Okay, this is done. So what we did was we used OpenJDK 8 and we have the image ready. So let me go back here and show you Docker images. You can see, uh, my Java app 8 is built, and there is my Java app with latest and my Java app with 8 OpenJDK 8. So that is the beauty of using Docker. I'm able to run with different JDKs with different binaries, or and couple of libraries attached to it, and still there is no issue, right? And I didn't install any of these packages. It was just directly from using something called as from command in Dockerfile, right? So that is the reason why Docker is such a Docker or container strategy is such an important thing for the futuristic app development, right? And now, if you see, now 8 is ready. So I'll just say Docker run and BAE, which is the image name. If I type, it says, hi developers, this is Dedicate, right? So this is how you can actually build two different versions, and I can use two different ways. And now what I can do is I can push this image. This image is not on cloud, not on the registry, right? It is not available to everyone. I only, as a developer one, I was able to build this application with 8 OpenJDK 8, and I'm just hosting it. But I want to push this to the registry which I have. So what I'll do is I'll come here and I'll find my Java 8, and this is the version 2. I want to push it. I want to push it to the registry. I have the registry already built. I'll show you how to do it while this is happening. So it has started pushing the my Java app 8 to the registry, container registry, and we can see what happens. It's getting started. So while it gets started, I'll show you done here. So um, I can just go here and go and create resource, and this is Azure portal, right? Just go and this is how it looks, when you log in. And by the way, and you can just go ahead here and click on create, and you can see there is a couple of things which is available. And what you can do is you can just say search for what service you want, container, uh, registry, and you can click on this, and you can say create registry, and you can provide whichever subscription you want to, you're running in, and then select the required resource group you want to create. You can either create new one, registry name, location, if you want to run it in an availability zone so that nothing happens to your container registry. Even if something happens in that specific region, you could do that. And you can select the standards, that is which one you want to use. In premium you have almost everything, and I've been using standard and other things. And this is a private endpoint as well. Like, you can have a public IP created for yourself, and create a private endpoint for your container registry. As of today, as of now, what I'm using is the domain created by the Azure. And then there is encryptions and other things, and you go back and review and create it. So that's how you can do it. And let us go back and uh, go to all resources, and this is my container registry. I hope you can see this. Okay. Okay, this is my container registry, and you saw that, yeah? This is the link to my container registry as well. If you go to the I think this got done. Okay, this is a link. to access your container registry as well. If you see this, if this is the part of it, and then this is the name of my container image. So this is how you can access it as well while pulling it. So you can just go back and pull that image through that. And let me show you the repositories which is there. So we created a repository. Right. So this was one repository which I had, and this is simple Java app which with the latest one which I had created and uploaded. And if you go back here and you can see all the things which is required from a JSON perspective and other things, how exactly it is designed. Let me go back to this, and you can see logs, not logs, sorry. I wanted to show you how you can see the diagnostic. I wanted to show you how you can see the output. I think either it is there in the logs or something. No. Active logs. Oh, that is in this, right? I can't run this. So let me show you here. Container instances. Create container instance. Use the same container test and create test containers and Azure Container Registry. I don't have admin user must be enabled, right? So I'm not enabled to access the image. So I need to go and enable that. Sorry, it was not ready from my end. Oh, I need to do that. Okay, got it. So let me go to dashboard. Yeah, discard this. Go to all resources. Go to the image, access key, enable this. So basically to use the registry, I need to enable this key. So this key is enabled now. Now all resources, dashboard, um, create new resource, go to container registry, sorry, container instance, create one, and let us use the containers, name it as test vs. This is okay to be created anywhere. Container, I've it's easy. So this is my Docker registry, I mean the container registry on Azure, and image is this version 1. This is the what I need. Networking, it's okay to have it on public, it's fine. For the test purpose, you can override using the command if you want to change something in the code. Otherwise it's okay. And you will just go and create this. So it's reviewing. So it reviews all things you're given is right or wrong, and then it just creates. But there is something which happened. uh, Push Docker version 2. So this is getting deployed. So let's wait for the um, the container to get deployed from the registry to the container instance to execute it. So it's basically what I'm trying to do is I have a container registry. I built the image, I created the image, I pushed the image to the container registry, and from that container registry, I'm trying to take that and you know use that image in the container instance. So what is container instance service? It's basically to run containers. You just give the containers to it, and then it will run these containers based on your requirement, right? So I'm just waiting for it to get deployed. uh, this push got failed last time, I think, because of network issues. It happens because there is many things it has to push from a complete JDK, and this time taking, it's only for the first time, and it's not like every time you do this, this time will not be consumed. But there was, this, since this is the first time this JDK is being deployed, it takes some time. Let's wait for that to deploy anyways. Go. So this is getting deployed. I mean, this is already completed. So let me go back to the resources. So this is my container instance, not the registry. Basically, this is what I was actually trying to figure out where exactly is. These are the containers which is um, running. So this is the container which is running, or it has run, and here is the log which is there. So this is what I actually did. So I can go back and overview and say start again, and then go back to containers and wait for the log to have come back. Now the time will change. Now the time which it took last time, it will change. It's in waiting state. Why? It's gone into waiting state. Let me stop this. Oh, I think while building the container, I didn't say restart when. Oh, I don't know where to change that as well. Ta-da. Let us try again. There's some issue with my network, or it's in pending state. Okay, so this is still getting uploaded, so I'll have to wait for it, but um, it's still running, so I'm just waiting for it to complete. Let's come back to this. If it has moved from waiting state to running, I mean run state or completed state. Okay, so any questions you have meanwhile while this getting uploaded? Any questions people have, just open your mics and we can discuss it. Probably I'll also move towards the Kubernetes and architecture of Kubernetes, other things once we can once we have the discussion done. Any questions from people?
Vivek, we have one question in the chat.
The chat. Oops, 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 oops. I don't even remember where is my. I don't see any of this. Okay, it's here. Okay, there is, if we do change in the code, do we have to create image and push every time? Yes, there is a change in the code and image has to be created and you need to push it. Otherwise, I mean, how will people get the changes? But most importantly, as I told you, right, it's pretty easy to build the code once it has been built for the first time. Since I had no setup, I had to create all this setup right away. It's taking time, but usually, it takes very less time if I have the setup ready for the first time. First time, obviously, it will take time. As I told you, this is still getting uploaded and it is taking time. I think last time it failed to upload because of the network issue. There is this heavy network issue which is there at my end. So it is still going through. I don't know whether this will go through as well, because if I see, um, it is stuck at some point. But it will definitely take time while you're doing it for the first time, but definitely it will work in the next, if you go back and do a push next time. And what is there in the alerts? What do you mean by alert, as in these alerts? It's nothing but you can build alert system. If these so most of these containers are always running. Whenever you put something in container instance, um, these containers are always running. So while okay, this container has run now, and you can also see the Docker. Sorry, you can also see code has changed and everything, and it got terminated. So usually the state is not terminated; it is always running. I have built a container which is just a simple executable. But in a real world scenario, if I'm doing a Python Flask, if I'm doing something else, this state is always running. When I do that, state is always running. That means the code is always accessible via an API, just like any other API which is available out there, right? So that is something about the container instance. So while something happens to it, you can actually build alerts to it. And when you build an alert, that means if it is not running, there's a log issue, you can actually create some alerts and keep it, and conditions and other things you can select and add to it, and add a rule to it in terms of what alerts you need to get. It is very simple to similar to uh, how you can set up alerts on your database as a service. If it's running towards this threshold or running more than this threshold, or there is some issues, when to replicate these containers, when this alert is coming in, you would replicate these containers, you will create more containers, more instances of these containers to be executed. So this is something which you can definitely do. So I don't think so this is getting pushed because of some network issue, that anyways we can leave it. Any more questions? Is it possible to start Docker in Azure using Docker run command? That is what it does. Doc container instance, you are actually nothing but you're providing that Docker command. You're running that. uh, uh, it's the same thing, the meaning is the same. If you open the container instance, you can see when I do the start, it does the same thing, Docker run command. But while creating this container instance, you notice that where I can provide the information towards the you know information towards the how it has to run, right? With the command, what command it has to provide and other things. I didn't give that, but it is possible to give that as well. What advantages does using Docker in Azure has over Azure App Service? So Azure App Service is of, it's, you can either use it without Docker, with Docker. Azure App Service is more from building fast and deploying it fast to the infrastructure. But you know that while you're using Azure App Service, you still have to choose the infrastructure. Here, here I'm not choosing the infrastructure. You're not choosing any infrastructure. You're just choosing the plan you want, and you're just deploying it there, and it is just getting deployed. And that is the difference. So, and also it can scale, and also it can scale and replicate and other things, and it is unlimited, by the way. And Docker, I mean, these container instances can be used with virtual kubelets from a Azure Kubernetes perspective, where you can scale the traffic. I mean, if traffic is coming in, you can scale it through that, through that traffic, right? So that is something which you can definitely do. Docker versus AKE. I don't know what is AKE. What is AKE? Which one is recommended to use? What is AKE? Azure Kubernetes or AKS is there? Azure Kubernetes. Okay. Azure Kubernetes Services, AKS. So basically, see, Docker is a single instance. I'll talk to you about it while I'm doing the Docker. Sorry, the presentation for the contain Kubernetes. Let me invoke that itself. So let us go deep dive into Kubernetes itself, right? And until now, what we did was there was a piece of code, a simple piece of code, which I took and I converted that code into a, how to execute that code, what are the dependencies for that code to be executed. All these things I packaged using Dockerfile, and I built that image, I packaged it and pushed that package to the container registry, and I'm hosting that in any of the strategies of container registry. It could be a private, it could be Azure public registry, which is available from provided from Azure from a public cloud provider perspective, or it is could be a Docker Hub. So I did one such strategy and hosted that application there. And then now we are taking that specific code to scale, and there could be multiple containers, right? And there could be um, we did discuss all these things. I don't want to go in depth with this, but there could be multiple containers. So what does Kubernetes do is it orchestrates containers. It's basically orchestrating specific uh, containers that could, in a real world scenario, an application could have 30 to 40 different containers, or 50 containers running, and different set of microservices running. So I need to orchestrate, I need to manage the hardware properly. I need to make sure that the hardware is I'm able to uh, use the hardware resources intelligently, right? So what does Kubernetes do is it orchestrates containers. It provides interface for you to manage the hardware. In fact, from a workload perspective, how do you manage your workloads on this hardware and make sure that you max utilize the resources which is available from a from a Kubernetes perspective. And then there is it is one of the best way is Kubernetes is a it's kind of a declarative, not an imperative kind of tool. When I say declarative, it means you are just telling Kubernetes that this is how I want hardware to be managed. I mean, this is the strategy, and how it does it, how it make sure it is all taken care, is none of our business. It's all about Kubernetes. And now Kubernetes takes that information, creates a plan, creates a way to manage it, and it does work on its own. So You're just providing your desired state, and it just takes it from there. So that's the ability of Kubernetes, and that's why it is used. And how does what is the difference between a Docker and Kubernetes? you know Docker or the container is a simple piece of code, and you're just packaging it. But there could be several containers and you need to manage, and to manage those containers is when the Kubernetes comes into picture, the Azure Kubernetes service comes into picture. So elements of orchestration, all these things are part of any orchestration tool. Kubernetes is one of the orchestration tool. Scheduling and affinity. Scheduling is nothing but you're scheduling your containers, right? And affinity or anti-affinities, whether this container needs to work with this container, or this container needs to be deployed with the other container, how to make sure best utilize the infrastructure to work with that, and monitoring failover system scaling, and obviously networking accessibility using service discoveries. Different set of services can be not deployed, we'll see that. And then there is coordinated apps upgrade. So this is from a deployment perspective, how you can deploy different containers um, through Kubernetes, and how the old versions can be removed and new versions can come in. So that is something which can be done through Kubernetes perspective. Um, so how does Kubernetes work? This is the architecture of Kubernetes. It is very similar to any master slave. There is agent nodes, which is worker nodes, and there is control plane, whereas it's called as master node. And then there is API server in the master node, which can be accessed through the API client. The client is nothing but kubectl. You would have heard many times, people using kubectl commands, which is the client, which is talking. It is nothing but an interface to talk to the Kubernetes cluster. And the cluster it could have many worker nodes, and there is master node. And then this master node has couple of components. One is API server, and the other is exec database. Exec database is a database you see here, right? This database is holding all the information required for the worker nodes to run. And there is scheduler and there is control manager. So the moment you give the desired state is designed in a YAML file. You're going to design it in a proper YAML file with the required desired state, and we will see an example as well while we do the demo. Um, so there is desired state which you are going to hand over to the API server, and API server takes it to control manager, and control manager decodes that desired state and hand it over to the scheduler. And scheduler is responsible for creating a plan using the exec. So exec is a place where all the information related to the cluster is available. So the scheduler is working with the exec, bring out a plan, and then hands it over to control manager and gives it to the worker nodes. So in worker nodes, you can see that there is something called as Cubelets. Cubelets is a simple binary which is acting as a heartbeat, right? And it's basically it is having all the information related to the worker node, and it is providing information back to the master node on what are the things which is running on the worker nodes, right? And it is the you know you know the plan is provided to the kubelet, and kubelet uses containers at the core and runs these containers. And by the way, it is called pods. Pods is nothing but um, you know it's basically group of containers or a single container. So it's a single unit of workload in Kubernetes. So whenever you're talking about a workload in Kubernetes, you talk in terms of pods, and pod can be a group of containers. It can be a single container. It's basically you're running pods in the worker node, and Kubelet is responsible for running it and providing the information back to the master node on what is the state of these pods which is running. and if it fails, it runs again. It is keeping making sure that it is making sure that it is always taken care, the desired state is taken care. And couple of other things which is available to access network related stuff and other things like cube proxies, and also fluent D for getting the logs and other things are all part of the worker node. Everything is installed on the worker node. So this is how Kubernetes works. This is the architecture of Kubernetes, and this is how it really works. And if you want to learn Kubernetes and you want to master Kubernetes, it's a well-designed learning path which is available. I keep giving this learning path to developers, whomever I meet, who says I want to learn Kubernetes, and you can go back and use this particular link which is there. You can just um, you know access it and download the PDF, and there is books available. There is nice videos from Burn and Burns. There are core concepts which is available, and there is advanced related stuff like architecture patterns and various other things. From a core concepts perspective, right, I have already discussed about pods. It's basically a basic unit for worker node or running containers inside of Kubernetes, right? And it is basically a simple containers which is running towards it. And namespaces. Namespaces is nothing but logically you're building in within the cluster. You're logically spacing out within the cluster. So if you see that, right, if you have a you know uh, if you have an engineering blog, right, engineering blog service, you're creating a namespace and you're creating pods under that, and you're calling it as a blog service. So when I say attach a service to it, it means how you can access these pods. So you need to access blob service, and ultimately you will access the pods. So that is an accessibility. It's a kind of an how do you access a pod is using service on top of it, and namespaces is part of that logically building that structure within your hardware, right? It is not a real physical spaces. It is logically building it. Logically you are connecting things together so that you can access something, and so that you can act on something, access something. Every other information is available at the exit, and scheduler uses these information to run these in a couple of things which is required. Replication set is it's pretty simple. I can have one pod with set of containers running, and I can replicate that into different numbers to make sure that I have a scalable model. And this is nothing but I can have 4 count, 10 count, 15 replications based on how I have to scale my application. So you can use replication set. We can tell Kubernetes that I want 5 replications of this container, and it will spin up 5 replications, not necessarily on the same worker node. It can be on different worker nodes, or it can be on the same worker node, different worker node, and various other things. I'll talk about daemon set, where uh, the same thing, same it's also nothing but a replication. But um, the most important thing is when you say daemon set, at least one pod, at least one pod is running on one node, and there is a use case for this, right? It's kind of example if I have to give you is say for example you have an elastic metrics beat daemon set, right? Or a file beat daemon set. You are extracting node information, what is happening in the one specific master node, and you are trying to extract that data. You can't go into different nodes and install metric beats, right? And not you can create a plan for that. If you have to tell Kubernetes that, hey, I want this specific container to run on all the worker node. Uh, Whenever there is a new worker node comes up, whenever there is a worker node available out there, just push this metric bit. So this is how you can install it on these nodes, and it can access these information from daemon set. So keep that in mind. And deployment is nothing but, as I told you, right? There's version 1 of your pod, there's version 2 of your pod, and you're pushing from version 1 to version 2, and you're replacing things from a version to version. um, that's something which you can enable here. So again, it's a roll, it's basically you're rolling updates. It is not, version 1 will not go off when you push just version 2, right? And it is a slow process. It replaces one replica set with another replica set to make sure that your versions are right, and you can also roll back if there is things are wrong, right? And you can definitely do that. So I can show you a demo, but it will take some time, um, because I'm sorry, but I don't have the setup. So I'll have to create a new setup for this. Um, Kubernetes service. Okay, I want to create it in my central US, and here is the versions which you can choose from. And obviously pool size, this is the number of nodes you want. I'll say 2. I can change the size. I'm selecting a size, going to the node pool. I don't want this. I can enable virtual node as well for testing purpose. Enable skill set is not required. Then there is authentication, role based disable, I guess, and encryption is not required. I'm going with all the default things. Enabling HTTP routing because I want to access it. Then there is container registry if I want to. I mean, we can definitely choose our own, but we don't want to do that now. Mm, Log analytics is disabled. Policies, okay, disabled. Tag and review. So this is how you can actually go and create a cluster. It's so easy. If you have to do this in manually, right, it's going to take a lot of time and effort to do that. So that is the reason why the Kubernetes as a service is something, a wonderful thing to have, and it's pretty easy to go and create a cluster. And I've just created a cluster now. Um, let's wait for the cluster to come up, and it will take some time to come up. Deployment is in progress. Okay, let it work, let it go. While it is happening, let me close all these things which is not required. So this is the desired state which I wanted to show you, right? This is how you can design a desired state for the Kubernetes. Basically, this is one of the example which we have, and it's very simple. It's basically uh, you know it always starts with different APIs. By the way, this has various kind. It could be a deployment kind, or it could be a service kind. So there are many different kinds, which the kinds which you can use. And in this example, I have used only deployment and service, but you can use other different set of kinds which is available. All these have different set of API versions as well. So if this is version 1, this is something else. So you have to keep in mind, and you have to keep following the things which is available out there. And this is how you can design it. You are actually providing the container details here. This is the container details which is available. I'm building a backend for it, and then there is app name, which is to match the replications is 1. I want to have only 1, and it is deployment. Basically, I'm deploying it, and also I provided some of the resources which is required for this particular container to run. The specifications is here, and also provided some port numbers and other things and the service, etc. The this is a service on top of that, where it is I can access this specific container through this service. So as I showed you in the one of these slides, right, I have to have a pod running pod which is having containers, and these containers can be accessed via services. So on top of this, there is service which I've created to access it. Similarly, for the front end development, I have created a different set of deployment, and with the different container which is here, you can see this is a different container, and then obviously it has its own set of things, and it is getting connected to Redis, which is backend, which is here. This particular information talks about you need to connect to the Redis, which is at the backend, and it is valued as backend. This is the namespace, or this is the label which we had given at the top, and then it is again can be added into the load balancer. Here we didn't add this into load balancer. This service is just a port, and we are opening the port, adding the port into this. But here you are actually adding a load balancer to access the backend, the front end. There's a load balancer attached to it. So this is how you can design a desired state. We'll have a separate session in May or sometime where how to build this, what are the things you need to take care, what is the different kinds and other things, and other things which is required. We're planning a session for that, specifically to building a YAML file, that we will take it up when we do that. This is how you can design your desired state. All you have to do is assign this desired state to the Kubernetes cluster through master through kubectl, which is out there, and then just run this uh, specific YAML, and then you can access the code. Okay, so still deploying. Just give me a minute while it deploys. Let us set up the command line as well. Create storage. So what I'm doing is I'm trying to use the Cloud Shell right now to access the master, to connect with the master. This is the reason why the Cloud Shell requires obviously the storage is to, well, you can create files there, you can store files there, you can work on those files as well. So that's the reason. So let me wait for this one also to get created. So it is getting created. So one of the advantage of having Cloud Shell is it has all the latest things installed on top of it. So you really don't have to be worried like install everything onto your laptop. It's available out there from the Cloud Shell to act on various things which you require. So for example, it could be Python, it's already there, um, or you want Docker, it's already there. Command is already available for you. So let's wait for Kubernetes cluster to come up. Once it comes up, let's okay, deployment is done. So let's go there. This is the resource group QVS. So let me go back. There are a couple of things which I need to do. I need to get credentials. I need to get access to the service, access to the Kubernetes cluster. So I need to give them the right set of details. So this is my resource group. This is my Kubernetes cluster name. I hope that is the one which I have. And then we will get the access first. Okay, I have it ready. Got it. So I have access is nothing but it is adding all the details which is required into my configurations of this CLI of your laptop as well. Even if you run this as a command, it will add it into your bash. That's it. So that's it. And this is the command to get all the node details. There are a bunch of commands in kubectl. You can go through the help and you can figure that out. There's a bunch of things which you can do. So get node details. This is the node details, which is we created with two nodes, and this is the node which is running. Okay, so all we need to do is to create code, which is the YAML code. What is the name of it? Azure -o .yaml, and I'm going to open this file and insert the code. I'm saving the file. So code is now available. Okay, so what you have to do now is very simple. Um, I'm not able to edit. Why? Okay, so now all I have to do is go and apply. When I say apply, it means I'm going to give the code to the um, uh, to the Kubernetes cluster, that is my master node. Once I give this, what happens is it goes to the API server to control manager decodes it, send that information to scheduler. It's actually pushing that code to the node. So everything is pushed now, and these are the things which got created as well. And you can see the service is running up and running, and this is how you can actually have the code running on the Kubernetes cluster. I'm just waiting for it to come up. It will take some time. Now it is coming up. This is the external IP, and I'm going to take this external IP and post it here. Um, I should be able to. This is a load balancer. Through load balancer from the front end, it is actually going to the backend Redis. So just wait for it to come up. What is happening at the back end is the containers um, are being pulled, and then these containers are getting run. So this container has been pulled through Microsoft's um, own container registry where these services are hosted. I hope this is going to take. It should come up. While it is coming up, you have any questions? Let me know. Oh, why I missed this? Yeah, any questions while things are happening? There's a nice book for Docker. I think you can take a look at that. Something today. Any questions? Let me go back to that. Yeah. So now I'm able to see code which is running. This is running on Kubernetes now, and blue or purple. Uh, that's the voting app. You are a blue person or a purple person. You can also go to this this IP address, and you can actually tell me you're a blue person or a purple person. So you can also reset. So basically this is the code which is running on Kubernetes. You can see that very simple. We did saw before this session, we saw container getting built. We hosted it in the registry. We created this YAML and use it for managing your cluster. At a high level, right? You can have n number of containers, whether it is packaged as one pod or multiple pods. And this, you can create a different set of namespaces, create different set of service to access these pods, and combine them with a different set of labels so that it can be accessed. So that is how you can actually use this, and we will see in May how to write this YAML file, and hoping that session will come through. Okay, so this is all I had to show. um, this is all I had. Any questions? I am open for questions now. No questions? You can also unmute and ask questions if you don't have to type it. Anyone? Questions? Any? Everybody understood Kubernetes? Thank you. Rashmita, are you there? I think, am I audible?
Yes,
Yes.
yes, yes.
Yes, yes.
You are
You
audible.
are audible. I didn't get that, Rama. I didn't get that. So you're still trying to visualize what is Kubernetes is? Okay. Cool. I think I know this is kind of a you know uh, end to end and new concept, and probably if you're first timers, it could be overwhelming, but it's pretty easy and pretty simple. Just go through that the link which I have given. Just go through that link, and it will be easy, and it will definitely help you in terms of learning containers and Kubernetes both. I think we can close the session if there are no questions.
Any more questions? Please feel free to ask. I mean, you can just unmute yourself and ask. Vivek is still here. We still have some time.
I know
Okay.
that a couple of things which I did. It's basically the other speaker has to be at doing it. I prepared this in half an hour, so apologies for that as well.
I think, Vivek, we are good to go.
Yeah.
So, thank you once again, Vivek, and thank you all for joining us today. I have shared the link for our feedback survey in the chat. Please send your feedback, it will help us to curate our topics better. And also, if you would like to watch sessions, so please visit to our reactor space. Thank you and good evening.
Thank you. Thank you all. Bye
Yeah.
bye.
Bye. Bye.